Welcome to Chapter 5, Infrastructure for Sustainable Technologies. So why do you, as a business student, need to understand the underlying technology of any company? Most people think that technical stuff is something they will never personally encounter, and for that reason do not need to know anything about MIS infrastructures. Well, those people will be challenged in the business world. When your database fails and you lose all of your sales history, you will personally feel the impact when you are unable to receive your bonus. When your computer crashes and you lose all of your confidential information, not to mention your emails, calendars, and messages, then you will understand why everyone needs to learn about MIS infrastructures. You never want to leave the critical task of backing up your data to your MIS department. You want to personally ensure that your information is not only backed up, but also safeguarded and recoverable. For these reasons, business professionals in the 21st century need to acquire a base level appreciation of what MIS can and cannot do for their company. Understanding how MIS supports growth, operations, profitability, and most recently, sustainability is crucial, whether one is new to the workforce or a seasoned 500 employee. One of the primary goals of this chapter is to create a more level playing field between you as a business professional and the MIS specialists with whom you will work. After reading it, you should have many of the skills you need to assist in analyzing current and even more future MIS infrastructures. The learning outcomes for today's lecture include define MIS infrastructure, and then identify the three types of MIS infrastructure, and finally, list the characteristics of an agile system. MIS infrastructure includes the plans for how a firm will build, deploy, use, and share its data, processes, and MIS assets, such as hardware, software, network, client, and server. Let's briefly explore these assets to better understand their role and purpose in the system. The hardware consists of the physical devices associated with a computer system. Hardware is the physical component of computing and includes technology like the keyboard, mouse, monitor, hard drive, etc. Without physical hardware, software cannot perform the function for which it is programmed. Software is the set of instructions the hardware executes to carry out specific tasks. Software is the programs that are needed to accomplish the input, processing, output, storage, and control activities of information systems. Computer software is typically classified in two major types: system software and application software. Your network is a communication system created by linking two or more devices and establishing a standard methodology in which they can communicate. The client is a computer designed to request information from a server. For example, when you are surfing the web, your computer acts as a client requesting information from the website. The server is a computer dedicated to providing information in response to requests from a client. So, when you enter a website, the website's computer on the other end is acting as a server, responding to your request for access to the information on their web page. An enterprise architect is a person grounded in technology, fluent in business, and able to provide the important bridge between MIS and the business. In many cases, you will have to act as this person when coordinating the solutions to complex business problems. We will now take a deep dive into the three types of MIS infrastructure: sustainable MIS, information MIS, and agile MIS. Sustainable MIS infrastructure identifies ways that a company can grow in terms of computing resources while simultaneously becoming less dependent on hardware and energy consumption with the goal of supporting the environment. A sustainable or green MIS system is the production, management, use, and disposal of technology in a way that minimizes damage to the environment. The general trend in MIS is towards smaller, faster, and cheaper devices. Gordon Moore, co-founder of Intel, the world's largest producer of computer chips, or microprocessors, observed in 1965 that continued advances in technological innovation made it possible to reduce the size of a computer chip, or the brain of a computer, even a cell phone nowadays, while doubling its capacity every 2 years. This is known as Moore's Law. Moore's Law has made technological devices smaller, cheaper, and faster, allowing more people from all income levels to purchase computing equipment. The increased demand is causing numerous environmental issues. E-waste refers to discarded, obsolete, or broken electronic devices. E-waste includes CDs, DVDs, thumb drives, printer cartridges, cell phones, iPods, external hard drives, TVs, VCRs, DVD players, microwaves, and so on and so on. Some say 1 human year is equivalent to 7 years of technological advancements. A personal computer has a life expectancy of only 3 to 5 years, and a cell phone is less than 2 years. It is the corporate social responsibility position to acknowledge a responsibility to society and plan for the safe disposal of MIS assets at the end of their life cycle. In addition to e-waste, huge increases in technology use have greatly amplified energy consumption. The energy consumed by a computer is estimated to produce as much as 10% of the amount of carbon dioxide produced by an automobile. Computer servers in the United States account for about 1% of the total energy needs of the country. Put in perspective, this is roughly equivalent to the energy consumption of the entire state of Mississippi. Computers consume energy even when they are not being used. For convenience and to allow for automatic updates and backup, the majority of computer equipment is never completely shut down. It draws energy 24 hours a day. The major human-generated greenhouse gases, such as carbon emissions from energy use, are very likely responsible for the increase in climatic temperature over the past half a century. Additional temperature increases are projected over the next 100 years, with serious consequences for Earth's environment if greenhouse gas emissions are not reduced. In the United States, coal provides more than 50% of electrical power. When left on continuously, a single desktop computer and monitor can consume at least 100 watts of power per hour. To generate that much energy 24 hours a day for a year would require approximately 714 pounds of coal. When that coal is burned, it releases on average 5 pounds of sulfur dioxide, 5 pounds of nitrogen oxide, and 1,852 pounds, that is almost a ton, of carbon dioxide. Combating e-waste, energy consumption, and carbon emissions requires a firm to focus on building a sustainable MIS infrastructure. A sustainable MIS infrastructure identifies ways that a company can grow in terms of computing resources while simultaneously becoming less dependent on hardware and energy consumption. The components of a sustainable MIS infrastructure include grid computing, virtualized computing, and cloud computing. Grid computing is a collection of computers, often geographically dispersed, that are coordinated to solve a common problem. With grid computing, a problem is broken into pieces and distributed to many machines, allowing faster processing than can occur with a single system. Computers typically use less than 25% of their processing power, leaving more than 75% available for other tasks. Innovatively, grid computing takes advantage of this unused processing power by linking thousands of individual computers around the world to create a virtual supercomputer that can process intensive tasks. Smart Grid delivers electricity using two-way digital technology. Most computers, and even servers, typically run only one operating system, such as Windows or Mac operating system, and only one application. When a company invests in a large system, such as inventory management, it dedicates a single server to house the system. This ensures the system has enough capacity to run during peak times and to scale to meet demand. Also, many systems have specific hardware requirements along with detailed software requirements, making it difficult to find two systems with the same requirements that could share the same machine. Through the use of virtualization, computers can run multiple operating systems along with multiple software applications, all at the same time. With cloud computing, an individual or business pays only for the services they need, when they need them, and where, much as we use and pay for electricity. In the past, a company would have to pay millions of dollars for the hardware, software, and networking equipment required to implement a large system such as a payroll or sales management. A cloud computing user can simply access the cloud and request a single license to a payroll application. The user does not have to incur any hardware, software, or networking expenses. As the business grows and the user requires more employees to have access to the system, the business simply purchases additional licenses. Rather than running software on a local computer or server, companies can now reach to the cloud to combine software applications, data storage, and considerable computing power. Utility computing offers a pay-per-use revenue model similar to a metered service, such as gas or electricity. Information MIS infrastructure identifies where and how important information, such as customer records, is maintained and secured with the goal of supporting operations. Consider this. What would happen if your computer crashed right now and you couldn't recover any of your information? What would you lose? Days, weeks, or months of information? Imagine taking a quick trip to the printer on the other side of the room, and when you turn around, you find that your laptop has been stolen. How painful would you find this experience? What types of information would you lose? How much time would it take to recover all of that information? A few things you might lose include music, movies, emails, assignments, saved passwords, not to mention that all-important 40-page paper that you took more than a month to complete. If this sounds painful, then you want to pay particular attention to this section and learn how to eliminate this pain. So what is backup and recovery? Well, backup is an exact copy of a system's information, where recovery is the ability to get a system up and running in the event of a system crash or failure. Do you have a backup strategy for your computer? How often do you back up? What do you back up? What type of format do you use for your backup? Where do you save the backup? And how long do you save the backup for? Management should have enough confidence in their backup and recovery systems that they could walk around and randomly pull out cables to prove that the systems are safe. Managers should also be secure enough to perform this test during peak business hours. Hurricanes, floods, fires, and many other types of natural disasters can have devastating effects on businesses. One of the most common types of hardware failures occurs from rats, mice, and squirrels chewing on cords, cables, and devices. The optimal recovery plan in terms of costs and time is where the two lines intersect. Organizations should choose a backup and recovery strategy that is in line with its business goals. If the organization deals with large volumes of critical information, it will require daily backups, perhaps even hourly backups, to stored servers. If the organization deals with small amounts of non-critical information, then it might require only weekly backups to tapes, CDs, or DVDs. Deciding how often to back up information and what media to use is a critical business decision. If an organization decides to back up on a weekly basis, then it is taking the risk that if a total system crash occurs, it could lose a week's worth of work. If this risk is acceptable, then a weekly backup strategy will work. If this risk is unacceptable, then the organization needs to move to a daily backup strategy. Again, some organizations find the risk of losing a day's worth of work too high and move to an hourly backup strategy. Union Bank of California has created a disaster recovery plan that includes multiple data centers in diverse locations, mirrored sites which can take over at the flick of a switch. These are called hot sites, where staff can walk in and start working exactly as they would if they were in their normal location, and a vast amount of redundancy. Hot sites are a separate and fully equipped facility where the company can move immediately after a disaster and resume business. Another option is warm sites, a separate facility with computer equipment that requires installation and configuration. And lastly, you have cold sites, a separate facility that does not have any computer equipment, but is a place where employees can move after a disaster. Natural disasters and terrorist attacks are in the minds of business professionals who take safeguarding their information assets seriously. Disaster recovery plans traditionally contained information on systems and data, ignoring cross-functional and intra-organizational issues for business processes and supply chain management. For this reason, many are turning to a more comprehensive and all-encompassing plan known as business continuity planning. Business continuity planning is a plan for how an organization will recover and restore partially or completely interrupted crucial functions within a predetermined time after disaster or extended disruption. A good business continuity plan includes a business impact analysis to identify all critical business functions and the effect that a specific disaster may have upon them. Touching on technology failure, which occurs when the ability of a company to operate is impaired because of a hardware, software, or data outage. The plan also includes incidents, which are unplanned interruptions of a service, and the corresponding incident management, or the process responsible for managing how incidents are identified and corrected. The Agile MIS infrastructure includes the hardware, software, and telecommunication equipment that, when combined, provides the underlying foundation to support the organization's goals. The goal here is supporting change. If an organization grows by 50% in a single year, its systems must be able to handle a 50% growth rate. Systems that cannot adapt to organizational change can severely hinder the organization's ability to operate. The future of an organization depends on its ability to meet its partners and customers on their terms, at their pace, any time of the day, and any geographic location. These are commonly known as the ILITEs. The ILITEs refers to the 7 characteristics of agile infrastructure. They are accessibility, availability, maintainability, portability, reliability, scalability, and usability. Accessibility refers to the varying levels that define what a user can access, view, or perform when operating a system. Consider how people with disabilities use the web. These are things we must be mindful to make our systems accessible. Web accessibility allows people with disabilities to use the web. You might consider a screen reader for visually impaired, or subtitles for the hearing impaired. Accessibility also refers to administrator access, which is unrestricted access to the entire system. Certain members of your team will require more access to system capabilities than others, and the assurance that they have that access when they need it. Availability is time frames when the system is operational. An unavailable system is the time frames when a system is not operating and cannot be used. High availability systems are continuously operational at all times. Availability is typically measured relative to 100% operational, or never failing. A widely held but difficult to achieve standard of availability for a system or product is known as the 5 nines, or 99.999% availability. Some companies have systems available 24/7 to support business operations and global customer and employee needs. With the emergence of the web, companies expect systems to operate around the clock. A customer who finds that a website closes at 9 p.m. is not going to be a customer for long. Systems, however, must come down for maintenance, upgrades, and fixes. One challenge organizations face is determining when to schedule system downtime if the system is expected to operate continually. Maintainability is how quickly a system can transform to support environmental changes. Organizations must watch today's business, as well as tomorrow's, when designing and building systems. Systems must be flexible enough to meet all types of business changes. For example, a system might be designed to include the ability to handle multiple currencies and languages, even though the company is not currently performing business in other countries. When the company starts growing and performing business in new countries, the system will already have the flexibility to handle multiple currencies and languages. If the company failed to recognize that its business would someday be global, it would need to redesign all its systems to handle multiple currencies and languages. Not easy once systems are up and running. Portability is the ability of an application to operate on different devices or software platforms. Apple's iTunes is readily available to users of Mac computers and also users of PC computers, smartphones, iPods, iPhones, iPads, and so on. It is also a portable application. Because Apple insists on compatibility across its products, both software and hardware, Apple can easily add to its product, device, and service offerings without sacrificing portability. Many software developers are creating programs that are portable to all three devices, the iPhone, iPod, and iPad, which increases their target market and, they hope, their revenue. Reliability ensures a system is functioning correctly and providing accurate information. Reliability is another term for accuracy when discussing the correctness of systems within the context of efficiency IT metrics. Inaccuracy is a vulnerability or systems weakness that can be exploited by a threat. Inaccurate information processing occurs for many reasons, from the incorrect entry of data to information corruption. Unreliable information puts the organization at risk when making decisions based on the information. Scalability is how well a system can scale up or adapt to the increased demands of growth. Performance of its scalability measures how quickly a system performs a process or transaction. Capacity planning is critical to determine future environmental infrastructure requirements that ensure high-quality system performance. Web 2.0 is driving demand for capacity planning. Delivering entertainment-grade video over the internet poses significant challenges as service providers scale solutions to manage millions of users, withstand periods of peak demand, and deliver a superior quality of experience while balancing network capacity and efficient capital investment. Given the success of YouTube.com and the likelihood of similar video experiences, the bandwidth required to transport the video services will continue to increase, and the possibility of video degradation will become more challenging. To ensure adaptable systems performance, capacity planning helps an organization determine future IT infrastructure requirements for new equipment and additional network capacity. It is cheaper for an organization to design and implement an IT infrastructure that envisions performance capacity growth than to update all the equipment after the system is already operational. Usability is the degree to which a system is easy to learn and efficient and satisfying to use. The system serviceability is how quickly a third party can change a system to ensure it meets users' needs and the terms of any contracts, including agreed levels of reliability, maintainability, or availability. Providing hints, tips, shortcuts, and instructions for any system, regardless of its ease of use, is recommended. Apple understood the importance of usability when it designed the first iPod. One of the iPod's initial attractions was the usability of the click wheel. One simple and efficient button operates the iPod, making it usable for all ages. And to ensure ease of use, Apple also made the corresponding iTunes software intuitive and easy to use. This concludes our lecture on Chapter 5. Be sure to read on, learn and understand the difference between private and public cloud computing.